Hello everyone. So in this video we are going to discuss about how to create a microservice architecture using NestJS, and this video is like how to implement the steps which are shown here in this Medium blog. So as you can see over here, there is a blog over Medium, and in this blog is how to implement a microservice architecture. Basically, the microservices, all microservices are based on Nest, and they are using Monorepo. And we are also going to discuss about what's the role of API Gateway and client app, or you can say backend for frontend. So if I scroll down over here in this current blog, so the mainly one thing I want to tell you first that is kind of disclaimer. So in this blog we are not going to discuss about what's the benefits of microservices architecture or microservices, what are the challenges while implementing a microservices, or any distributed transaction pattern using Saga, or scalability, maintainability, and all about the deployments. So it's just a communication between a microservices, and all are purely Nest based microservices. So if I go over here the Nest documentation, if I go over NestJS official documentation, and over there if I open a microservices page here, and there is, if I do overview over there, so we are going, I try to implement this complete steps or the theory written over here in this blog. So there is mainly a two pattern discussed over here in blog. One is message based and another is event based pattern to make a communication between microservices. So here if we go back in our blog, so let's so as already I have said that we will this blog will cover these questions like what is Monorepo, because we are going to implement those microservices in a Monorepo approach, and architecture, in terms of architecture we are going to create 3 to 4 microservices, and how to make communication between them, right? And API gateway, as I already said, and backend for frontend. So standard mode, if we create any NestJS application using first we install a Nest CLI, and then using this command we create any NestJS based microservice or application. So by default is a standard mode. Standard mode is just simple pure Nest application, nothing else. Okay, and if we leverage the standard mode into Monorepo, there is a list of command I have also written over here, and I have implemented the same commands and created the code, and same code I have also published over GitHub. So you will find the same replica of code which are written over here in this blog. So so Monorepo basically a group of microservices. You can find it as unified way or at one particular place, right? So first we have created the microservice, and then using this command we will back to our parent directory, and we are going to create one library. So library basically, if we want to share a code between different microservices or repositories, then we can create a library. And if you run all these command, right, which are shown over here, then you will come to know that your repository in VS Code will look like this, as shown over here in screenshot, and also I am going to present over in VS Code. So if we run all these command like app user, app products, get API gateway and client app, so this will look like this. Okay, and I have also shared a Nest CLI JSON file. So after running all this command, my Nest CLI JSON will also look like this as shown in this blog. So there are some benefits of Monorepo. I said that. Okay, so now we have created microservices. They are all based on Monorepo, right? So if I go over here, we have also created this library. So I have given name just my library, and I have created some couple of common DTO and some couple of util services. So how can I import these common functions in my different microservice? So if I go over here in client app and just go to main.ts file, okay, module file, okay, or if I go over here to app user module file like app user, then you can see that my library module. So this module has been exported, and you can using this way in different microservices. So you have also learned like how to implement this common library. Okay, so now we will move to our main topic, or the main aim of this blog or video: the communication between microservice using point-to-point communication, and other is or we can say a message pattern based communication, and another is event based pattern, right? So if I show you high level picture of how this gonna be work, or how this communication will happen. So here is just a sample screen, sample bird eye view, the diagram, which shows that how the request will originate from client or the external client which exists over the internet, and how this request will propagate over this microservices, client app, API gateway, and give a response to the client. So as of now, you just got a high level overview how the request will propagate it into our system. Okay, so how to so let's start to implement communication between microservices using message pattern and event pattern. So event pattern is just like some broker is running, and microservice will listen to the all changes, and one microservice will publish the event. So it basically pubsub event, publishing and subscribing the event. So for example, okay, and point-to-point communication is like opening a TCP port over the microservice and start sending the message to that particular microservice, and based on that message pattern, microservice will listen to that message and return a response. So for example, what gonna be here is like first, whatever the request will come from the client, external client, will first reach at client app or backend for frontend, then backend for frontend. Okay, so before understanding, so before going further, why we are going to implement a backend for frontend or BFF. In this video I will say this word. So what's the role of that? So BFF is purely focused about how to give a response to that particular client. So it's the main role of this backend for frontend is tailor the response as per the requirement of the UI. Okay, so and also same discussed over in this blog. Okay, and next is API gateway. So API gateway is like a brain of microservices. So based on the message, which microservice, so based on the request received from the client app, to which microservice API gateway has to propagate or forward this request, and so basically decide which microservice will give a response for this particular request. So here we are going to implement a point-to-point communication between a client app, API gateway, and app product microservice, and PubSub based communication will happen between API gateway and app user API. So here we are also using a Redis for the PubSub communication or a message queue. Okay, so if I go over the code, so first is API client. So here in API client, what I have done in the app module, so API gateway is also one kind of microservice, and communication between client app and this API gateway is based on the TCP. So I have informed the client app, like on this particular plot 3005, the API gateway is running and communication between you and API gateway is based on TCP. So if we go over here in API gateway, then if you open a main.tspl file, then there is a 3005 port. So if you see over here that there is a 2 port mentioned over here. So one is 3005 and 3003. So why we have used 2 ports? So basically we have leveraged a Nest Connect microservice interface. So this basically written a iNest application. So this is gonna be a hybrid mode. If we see the documentation, then you can see over here that there is a hybrid application option. See, so based on the using this, we can inform the microservice, or we can run basically microservice on a 2 port. So this will listen on 303 and 305 as well. So why we are doing this, you will come to know later in this video. So here client app will directly communicate with API gateway only. So if we see over here, like in API gateway, there is a okay. So in client app we have what we have done, only inform that you have to communicate with API gateway only. But in API gateway, what we have done, we have API gateway module, we have incorporated 2 modules or 2 microservices like app product and app user. So as you can see over here, there in API gateway we have incorporated 2 microservices, app product and app user. So basically we are telling to the API gateway that you can communicate to the app product and app user microservice by injecting them. So if I go to our controller service, so what I did here is just injected to both the services, right? So the communication between the API gateway, as you can see over here, API gateway and app products and API gateway and app user can be done with using a point-to-point communication using TCP. So if we go deep dive into the app user API, so then you can see over here that we have used a hybrid approach, right? So what we have tell to the app user API that you can run over or you can connect to the port 6379 on which Redis queue is running, and microservice itself is running on 3002 port. So if I write down here everything, like on which port which service is running, so if I go, so you can see over there on app user API gateway is running on 303 and 3005 because it's a following hybrid approach. Another client app is on 3004, app product is 3001, and The microservice which we have created starting is on 3000. So if I go to the app product API, and here if I open a main.ts file, that is only on 3001, so only listening on 3001 port. So if I sum up the everything, so if we request app product and app user, then API gateway will post the request coming for the app user service will on queue of Redis, and app user service will listen to the messages coming on Redis queue and revert to the API gateway. So you can see over here, if we can see in a client application, there is a client app controller. There is a, for the communication, for the point to point communication, there is a mechanism called send. So yes, send, using if you want to communicate between two microservices using point to point, then we have to send. And if you want to communicate using event, so for event we have if I go to API gateway, and at API gateway we have emit. So communication for between API gateway and user service is based on event. So whatever event is published by API gateway will be listened by the user service, and based on that user service will revert response to the API gateway. And if API gateway need a response from app product service, then basically it is sending through a message pattern. So for example, if I go to API gateway controller, and you can see if I request for creating a new product or getting the list of product, then here is a send. So if we see over here in message pattern, if I do little bit zoom, there is a get product underscore request, and for adding the product I have defined one key for message pattern. So based on this key, both this key, app product will listen to that particular message pattern of the key and revert a response, and that response will be reverted by API gateway to the client. So so basically this is a point to point communication and event based communication between microservices. So it's the same thing which I have shown over here in a VS Code is reflecting over here in a blog. So now after the this end of this blog, if I see over if I show you how to run a service, then you have to add these lines for normal run and for in run with debug mode, or you can sort a dev mode. For these services you have to add these lines. So if I open our package.json file, and we can see over here this line is written. So what I have done, I have run all these services for client, API gateway, backend for frontend, client app, API gateway, user microservice, and product service. So if I do a request, for example, first to add a product. So for example, if I am adding a product like phone, and let's say for example price is like 1000 just so if I do a request, okay, so you can see what the response has been returned, and this request is originally hitting to a 3004, and on 3004 we are running a client app. So sorry, client app will forward the request to API gateway, and API gateway will forward to the product service, and based on that we are getting a response. And if you want a list of products, so again you can see there is a 3004 port, so it's a client app port. So if we hit a request, then you can see over here there is a phone we have entered or we have inserted, we are getting back. So again, if I so this is a point-to-point communication happening. If I want to show you how to communication between user app and API gateway through event, basically on based on queue or Redis queue. So if I want to add like for example say Anil, I am adding Anil and there is some mobile number. So if I hit send, so you can see there is we are getting a response of 20. Again it is hitting on 3004. If I show you a console of user service, then you can see over here that this business logic on event user created receive. So if I go to the code of user service, so basically here a user service is running and here the event has been received using a broker or Redis. So the event has been published by API Gateway and that event has been received by a user. And so here you can see I have written a log like business logic on event user create received. So based on this, the logic written over here will execute, right? So this is the communication. So basically this is how communication can be happen between microservices. So I have just run the 4 services and did the communication between them. So I have also added the link of this entire Postman collection to add product, user, and getting a list of product. Also published over this Postman collection has been published. And if I go to little bit, so here I have also mentioned that I am going to add another block or part 2. This is a part 1. So in part 2 one interesting case study of how we can communicate using a gRPC. So right now we are doing a communication using a event and message pattern. So if I show you over here, so for example you can see this is a TCP communication transport we have used, and we have used Redis and other there is a net MQTT RMQ Kafka based on the event pattern or the message queue. But there is a gRPC which run over HTTP2 and we have to use a proto buffer and all those things for faster communication. So gRPC is like a remote procedure call, so you are getting a response as much faster compared to the TCP. It's like you are calling a local function. So I am going to add part 2 with gRPC and here I also added a link where how LinkedIn has reduced the latency up to 60% by implementing a gRPC. So if this link also has been mentioned in a blog, and you can see that gRPC offers better performance. So my next part is with gRPC. Okay, so one practical use case, what I have done, I have communicating between API gateway and client app using a normal HTTP call. So if I go to my API gateway controller, and there is an endpoint one called products API. So this products API will be called by client app using normal HTTP call using XUs. So if you see over here, I have also defined one endpoint which run in a client app at 3004 port, and it is calling the API products API which is running on API gateway. So for example, here if I open my Postman, then you can see there is two APIs I have opened. One is product API and another is only get product. So get product is directly calling TCP communication using point to point. So if I request to get a products, so you can see over here it is we are getting a response 200 and 106 millisecond. If I continuously hitting, then you can see there is every time I am getting a response like 6 second, 10 second, 7 second, 22 second, 7, 9, 25. Okay, so and so in very fast. Okay, and if I open the product API, and this is the normal HTTP call, and if I hitting the API, then again you can see every time there is 42 second, then 22 second, 37 second, 38. So this is higher compared to direct this TCP communication. So this is very fast, like 9 milliseconds, 6 second, 5, 8. I am continuously hitting this. Okay, and here also I am hitting a continuously. So this interesting use case I am showing how communication point to point communication using TCP and is fast compared to the HTTP communication, which is going to happen between client and API Gateway Microservice. So you can see over here, so on different port our microservices are running, like I have shown that on app product is running on 301 and user 302 and 3 and 305. So we are always hitting from or REST point like Postman to client app, and client app is communicating to API gateway, and API gateway is defining to forward which request to which microservice, and based on that we are getting a response back to in our Postman.